Hello everyone, in this video session I'll be continuing the design of rectangular weir. The last session we have designed the length of the weir which is 16.5 meters. Okay, and let us continue the remaining dimensions. Let us find the remaining dimensions of the waste weir. So that depends upon the FTL and hard strata level. So the full tank level it is 928.15, and the hard strata for the foundation let us consider as 923.15 at the ground at the site, and therefore the structural height will become 5 meters. So 928.15 minus 923.51 will be equal to 5 meters. So then the top or the crest width of the waste weir can be calculated by this formula: 0.55 into root of h dash plus root h, where h bar is the height of the weir and where small h is the head over the weir. So we will have a maximum water level which will be flowing, and we know the difference between maximum water level and FTL is equal to 1 meter. So 929.15 minus 928.15, which will be equal to 1 meter. Just substitute that here. So the A value will be getting equal to 2.34. Okay. So now I'll just take approximately it is equal to 2 meters. Then the base width of the weir that can be calculated by h plus h divided by root of rho minus 1, and here take the value of this is 5 actually. Take the value of h is nothing but h dash. Okay, so h is equal to 5 plus small h is 1. 6 divided by root of 2.25 minus 1 will give you 4.66, and you can take it equal to 4.5 meters. 4.7 meters will be the base width. So that will complete the design of waste weir. So next, let us consider the design of channel. Before design of canal, we need to calculate the diameter of the tank sluice for allowing the water to flow from reservoir to the canal, and for which we need to consider the total discharge of water to be done to the canal. So the total area of irrigated land can be taken as approximately 40 hectares, and this can be obtained by Google Earth, and I have traced the command area here. This is the area to be irrigated, and this can be chosen based on. So this is actually the upstream side of the bund, and this is the downstream side, and this is the canal alignment, and this will come here, and we have stopped here, and from this point we will be supplying the water to the downstream side. This will be the one, and this is the mother valley. From here it will flow and it will reach here, and it will go like this. This is the mother valley, it will go off. So the other side of the mother valley will be cultivating. This is the cultivation land. Okay, so in order to do the cultivation, so this area needs water, and that can be supplied through the canal, right? And that in order to allow the water to flow, there should be opening which has to be made in the tank sluice. So that has to be calculated. So 40 hectares is the area, and then for future expansion 25% if you consider 10 hectares. So 50 total it will be 50 hectares, and then assuming the duty due to all types of crops, maybe ragi, maize, and rice, etc., and vegetables, all that as 1000 hectare per cubic, we can calculate the discharge. Duty is equal to area to be irrigated divided by discharge, or discharge is equal to area divided by duty. So total area to be irrigated is 50 divided by 1000. It will give you 0.05 cubics. Okay, cubic meters per second. And since more water is required for KR period, discharge may be increased by 30%. So total discharge is equal to Q, which is equal to 0.05 plus 30% of 0.05, it will be 0.015. So if you add that 0.065 it will be, so approximately take it to 0.1 cumex, and so this can be used for finding the diameter of the tank sluice. So in order to calculate diameter of the tank sluice, you can use this formula: Q is equal to N into CDA root 2GH, where N is the number of vents or openings which has to be made. So assuming openings equal to 1 and CD is equal to 0.66 for circular opening, so A is equal to Q divided by NCD, and if you just substitute all those things, 0.1 divided by 0.6 root of 2 into 9.81 into 1, so we will get the area of the pipe, the vent should be equal to 0.051 meter square. And let us design a circular opening, which that means A is equal to pi d square by 4. So D will be by substituting A equal to 0.015, will be getting diameter is equal to 0.255 meter, and approximately you can make it equal to 0.3 meter. So this will be the diameter of the vent which you need to make. Okay, so provide 0.3 meter diameter of the vent to carry amount of 0.1 cumex of water. Okay, this is to be provided at the sluice level for opening the water. Okay, so that completes the design of tank sluice vent.